Okay, so to simplify things with linearity, let's try to use a simplified approach over here. So let's assume that we know that we have an input x1 of t resulting in an output y1 of t, and another input x2 of t resulting in an output y2 of t. The system is said to be linear if a1 x1 of t plus a2 x2 of t results in an output a1 y1 of t plus a2 y2 of t, where a1 and a2 are constants. In other words, if we have a new input x of t that's basically a linear combination of x1 and x2, if the system is linear, the output will be a linear combination of the corresponding outputs y1 and y2 with the same constants a1 and a2. In more general terms, a summation of ai times xi of t will result in an ai times yi of t, which is the expression we have seen in the slides. But here we're trying to simplify things, so only two inputs and their corresponding two outputs should be enough. And let's try to do two examples we have seen in the slides, but to solve them using the simplified notation over here. So let's say we have a system y of n whose output y of n equals n times x of n, and we want to check the linearity. So we will assume we have an input x1 of n resulting in an output y1 of n. As we can see here, y1 of n would be n times x1, so y1 of n is n times x1. Same, we are assuming we have another input x2 of n resulting in an output y2 of n, which is n times x2 of n. And now we will have our input x of n, which is composed of x1 of n plus x2 of n, a linear combination of x1 of n and x2 of n using the constants a1 and a2. Let's try to find the output y of n. The output y of n is n times x of n, and x of n is simply a1 x1 plus a2 x2. In this case, we can move n inside the bracket and we will get a1 n x1 plus a2 n x2. n x1 is y1 and n x2 is y2. So now we will have a1 y1 plus a2 y2, which will give us a system that's linear because we had a linear combination of the inputs x1 into x2 when we got a linear combination of the corresponding outputs y1 and y2. So this relation is satisfied and now we have a linear system. Let's move on to another example where y of t, the system output y of t equals x of t times x of t minus 1. And let's see if this system is linear or not. So as you can see, using the same approach, we will let x1 of t to be input to the system and the output would be y1 of t, which is x1 of t times x1 of t minus 1. And assuming we have another input x2 of t, we will get y2 of t, which is x2 of t times x2 of t minus 1. Now let's assume we have an input x of t, which is a linear combination of x1 and x2. So let x of t be a1 x1 of t plus a2 x2 of t, and we need to compute the corresponding output y of t and see if this output y of t will be a1 y1 plus a2 y2. In this case, the system will be linear. But if y of t is not equal to a1 y1 plus a2 y2, then the system is not linear. So let's see. Y of t equals x of t times x of t minus 1, but x of t is a1 x1 plus a2 x2, and x of t minus 1 is a1 x1 of t minus 1 plus a2 x2 of t minus 1. These two are multiplied together. So this will give you a1 squared x1 of t times x1 of t minus 1, which is this term, plus a2 squared times x2 of t times x2 of t minus 1, which is this term. And then we get the cross term, which is a1 x1 times a2 x2 of t minus 1. So a1 a2 x1 of t x2 of t minus 1. And the other cross term is a2 a1 x2 of t times x1 of t minus 1. As we can see, x1 of t minus 1 is y1 of t. And x2 of t minus 1 is y2 of t. So now we have a1 squared y1 plus a2 squared y2 plus 2 cross terms. So it's clear that this is not equal to a1 y1 plus a2 y2. First of all, this cross term or these cross terms will make the system nonlinear. Additionally, we are expecting a1 y1, not a1 squared y1, not a2 squared y2. So this system is non-linear. And these two examples basically cover are good examples, will help us to learn and understand the linearity. And in this video, I'm trying to simplify things. Instead of using the summation, form here, we only had two inputs, x1 and x2, and just two outputs, y1 of y and y2, instead of having the general case of summation of inputs xi and summation of outputs yi.